1. We have ignition and liftoff of Atlantis and the Galileo spacecraft bound for Jupiter.
Almost 3 decades ago, Galileo, the only other spacecraft to orbit Jupiter, blasted off.
Roll program initiated about 110 degrees.
It too journeyed across the void. But once at the gas giant, things got a little odd. The spacecraft sent back some images that were almost totally white. An onboard spin detector stopped functioning, and Galileo would randomly switch into safe mode. It didn't take long to realize that this was radiation around Jupiter, pummeling the spacecraft's electronics. The images being beamed back from all over Jupiter are stunning. But they also create more questions. What produces the iconic stripes of wind we see in the atmosphere? How deep do those winds go?
Sunlight and the internal heat flux have been combined in a model.
Finally see if that prediction is right.
It appears that the winds that we measure at the tops of the clouds have routes that go down kind of parallel to the polar axis, north to south. So that's as deep as they possibly could go.
As predicted, Jupiter's huge bands of wind mark just the top of great rivers of atmosphere flowing deep within the planet.
We're talking winds thousands of kilometers below the cloud tops.
Even the Great Red Spot, a storm that could swallow the Earth whole, was found to have a route as deep as Juno's instruments could measure.
It could go down thousands of kilometers. That pretty much answers the question that we had, is the red spot shallow or deep? And the answer is...
For a long time, it was thought that each world formed by a gradual process.
You start with dust grains. Those dust grains somehow smush together. They get bigger and bigger and bigger until you get pebbles and rocks and boulders, and we sort of keep walking up the size ladder, and then those big bodies smash together to make the cores of planets. But it's not clear that that process is going to work fast enough to explain something like Jupiter, because one of the big problems with that model is that it takes a long time to go from little tiny stuff like this to a big honking planet like Jupiter.
Scientists believe that Jupiter formed perhaps just a few million years after the Sun. So there needs to be a mechanism that works quickly.
On top of that, it's really hard to make rocks stick together. You know what happens if you throw 2 rocks together? Nothing, right? They didn't grow, they don't stick together. The same kind of thing happens in the early solar nebula.